Okay, hello there. This is Michael again with another video on SAP 2000. And of course, as you can imagine, all the people who know and have seen the previous videos, I'll be using some of my favorite techniques. Now, before I show you what we have here on this AutoCAD drawing, I want to walk you through the problem. Now, the problem is a bank building that is going to be built in London. It's a 7-story structure, not too big, nothing too impressive, but our fellow architect requested that the spans be as large as possible. So as you can imagine, the solution came in and the spans are as large as possible. So what we're looking at here is 11 by 11 meter span. So you can imagine, or at least the people who can appreciate the forces and the loads that are being incorporated here, that the beams and column sections that we're talking about are significantly big. So the solution is 40,300 steel sections. And why? So the problem that we are dealing is that this beautiful building has inclined facades. To add to the extra weight, we're talking about glass cladding all over and power foundations that have already been discovered on site from a previous demolished building, which cannot always be a bad sign. Maybe the piles can be used, and that's a different problem. We care about the structure of this beautiful thing. And the solution came, as I said before, by using 40,300 steel sections, and that means a lot of space frames. So I've already designed the frames, and I've already taken this drawing here, this wireframe, and I've imported that into SAP 2000. I've assigned the members, I've added the loads and the forces, and long story short, here is what this looks like. So it's a big building, it's a very heavy building, and let's have a look. So as you can see here, this is how it looks with the space frames. Now I'm trying to zoom into this, and I'm using a very good machine, and it takes quite a bit of time to actually do that. So using that very simple technique that I've previously shown on my first video tutorial, I was able to design this very, very beautiful building. And just to have a look at how many sections there are in here, which I think I'm not wrong, there we go. There we go, 40,300 frames. Beautiful. Now, let's run the analysis on this building, and I want to show you how to check sections using the codes of practice. This building is designed for the UK, so the codes that are being used here is Eurocode 3. So let's have a look at running the analysis and see how that responds. We don't want to run the model analysis for this because it will take about a week to run. So let's have a look. One thing to know when you're dealing with big models and complicated models, you need to be using a very strong machine because you're going to be dealing with a lot of crashing. Now, that's not a particularly nice issue, especially if you're like me and you're a little bit impatient, and especially if you want your job being done. But it sometimes works, especially if you're patient, or at least you have to. Now, after having reviewed how you check each section with respect to the Eurocode, I will go through how to export this beautiful building into an AutoCAD model and start doing your detailing over that and start getting your dimensions out of it. That's not a very difficult procedure. As a matter of fact, it only takes a few minutes. but it's very helpful, especially when you're dealing with complicated structures. It's very helpful to know how to export from SAP 2000 to AutoCAD. So let's wait for the analysis to be done here, and we will be having a look on how to do that and how to be checking these sections. So now that we have the structure analyzed, the first step that we want to do is check our sections comply with the Eurocode or the AISC or any code of practice that we are using. For this, we go to the Steel Check tab, which is here. Now I'm going to click on this arrow and I'm going to view and revise the preferences. Here I've already checked Eurocode, but you can check any versions of the codes that you like. There's the Italian codes, which now have been void. There's the British standards in there as well. American Institute, there's the Chinese codes in there, every code that is available. Well, not every code that's available, but most of them. So for this structure, since we're in the UK and since the new Eurocodes are in, we're going to be using Eurocode 3, the 2005 version. Those of you who are familiar with the combination equations, we usually use combination 6.10 or the maximum between 6.10a and b. In this case, I'm not going to be so bothered with this, so I'm going to just keep that as 6.10. Now, I'm not going to change any of the factors in here because those are checked directly by the code, and I'm just going to hit OK. Now I'm going to click this little tab here and I'm going to wait for my loader to finish. Now a good sign would be once you see your loader, you see that bar moving about, that means that it's checking that particular section at that particular time. Now there's a set of equations that would run through to do the checks, and in this building, in the worst case scenario, I have designed it so that some of the braces fail. Now that's not a very recommended procedure through the codes of practice, and it's not very liked for very apparent reasons, but for this situation I done that quasi-intentionally just to see how the structure will respond after that is done. Now just keep in mind that there's more than 40,000 frames in this building, so at this point I am going to pause this video and come back to it when it's done, and I will show you how to check the reports on these sections. Okay, so now SAP 2000 has finished checking all the sections in the list, and as you can see, it fills the page up with all those colors. Now what we want to do here is zoom onto one of these sections that have failed, and I'm going to click on it if I manage to, and then I'm going to right click on it and see the structural report. Now it tells me at which of the load cases this has actually failed. So now I'm going to click on details and I'm going to check this out. So let's make this as big as we can. Alright, so now we're looking at one of the braces. Now it gives me an error that the section is overloaded, and here's the axial loads in that section and the moments, etc., etc. Now I know that normally you design braces to be pin connections, and this is actually the case here, but unfortunately I haven't defined my SAP model of those joints correctly, and as you can imagine, if you got 100,000 joints to play with, you're bound to miss some. However, in reality, hand calculations show that these sections with a pinned connection will experience this point load running through them, the compression load, but they would not experience any moments. So This section now is experiencing these kinds of forces. Now let's have a look at where the section is overloaded. Now this is the moment capacity of the section, and this is the moment that is existing. Of course, we are talking about a circular hollow section here, so it's not subject to lateral torsion or buckling or any modes of moment and bending failure in that respect. But still, if this was a pin connection, if this was not a pin connection, excuse me, then we would be experiencing a very big problem with respect to the moment that is being applied to that section. So now let's have a look at trying to get rid a few of those lines. Now I would like to get rid of the joints, so let's get rid of those, which is gonna help the situation a little bit. Now let's get rid of the areas as well, so that we can have a better look. And there you go. This is how complicated the structure actually looks. Now I think it's a bit easier if I just zoom out and then zoom in to the sections that interest me the most. Now let me zoom in to these space frames. As you can see, the frames are made of a lot of complicated sections. So the next thing that I said I'm going to do is show you how to export this into an AutoCAD DXF file on which you can actually play with respect to dimensions and stuff like that. To be able to export this building now into an AutoCAD file, allowing you to take out dimensions and any other stuff that you need from it, you first of all need to make sure that you don't have anything selected, because if you do have anything selected, it will just export those items that you have. So I'm going to click on the void there, and I'm going to hit escape a couple of times just to make sure that that command's gone through. Now I'm going to go into file, I want to go to export AutoCAD DXF, I'm going to choose a name, and I'm going to call this S7 Final, say DXF. And I'm going to save this on my desktop. Now SAP2000 is going to ask if you want to use an existing template that you can predefine from AutoCAD 2000, but I want to click no here. I do have templates, but I'm not going to use them. And now SAP2000 will allow you to choose what layers you want to add what into. I don't want to use the joints here, so I'm not going to select a layer. I want to use the frames, and I want to use the shells, so I'm going to be throwing these two. And now I'm going to be clicking OK. Now I think that we're done. Let's go into AutoCAD 2000 and check that. Now on my desktop I should have Final DXF. There we go, 6 megabytes. That's a good big file. Now let's have a look at this baby. Let's pull you into full screen. So there we go. Now we have our building. I actually think that the frames are on there. The shells are on there as well. So let's have a look at the realistic views. There you go. So I hope you enjoyed this video, and I'm probably going to be making another one on cables tonight. I hope that this was helpful to most of you, so stop scratching your heads, and if there's anything that you would like me to look at with respect to SAP2000, please do not hesitate to put that on the comment section below or private message me. Thank you very much for spending your time on looking at this video. Good night.